Sorry, my book bag.
Hey, worksheet number 3 on 1.5, fraction 2. Well, actually, this is not review. This is new stuff in Algebra 1. On the third worksheet, we're introducing one new thing. Look at problem number 1. What is it? X squared. Right, we're introducing more than one x being multiplied together. Okay, so if I don't have an exponent x, what is there that we don't normally write in? It's to the first power, right? There's no exponent there. It's to the first power. Now, notice that I'm going to rewrite this to show you what's going on. So I have 4 times x over 3 times 2 over 2. Now this x squared is x times x. Okay, so that's what's really going on with x squared. Then I go and do what we've learned on the first 2 sheets. Well, I can take out a factor of 2 from the 4. So 4 divided by 2 is 2. 2 divided by 2 is 1. I can factor out one of the x's. Okay. So, and then I multiply across. Well, yeah, these are 1s because I'm canceling them out. So 2 times 1 is 2 times 2 is 4. Then I have 3 times 1 is 3 times 1 is 3 times x is 3x. Yeah. All right, let's look at number 3. Let's see. I only have one factor of n in both, so they're going to cancel out. I got a choice here. I could either take the 2, divide it into 10. I could take the 2, divide it into 6. So 5 goes into 10. I think I'm going to do 2 into 6. So 6 divided by 2 is 3. 2 divided by 2 is 1. 10 divided by 5, 2. 5 divided by 5 is 1. Okay. So I end up with 1 times 1 is 1. 2 times 3 is 6. And now, you could write this out the way I did up there. Write it as 9 times x over 6 times x times the fraction 9 times x all over 3. Okay, let's cancel out some factors of x. Now remember, they have to be on the top and bottom. I can't cancel out across. So I can cancel out a factor of x. That's it. Okay, now I have numbers. Let's see. 3 goes into 9 how many times? 3 goes into 3 how many times? Ooh, 3 goes into 6 how many times? 3 goes into 3 once. Is that it? Looks like it. Well, 2 does not divide it to 9 evenly, so we're going to leave it. Good? Are we good?
What? What's the other thing?
Because I took 3 as a factor of 6. Okay, first, the 3 was a factor of 9, I got that 3. Then I took 3 was a factor of 6, so I crossed that 3 up.
Oh,
I actually used 2 factors of 3 for this 9. Because 3 times 3 is 9. In other words, I could bust that 9 up. I could have this. 9 times x over 6 is 2 times 3 times 9 is 3 times 3 times x all over 3. Okay. So when I factor out a 3, okay, then I can factor out these 3's. That's what I did. Okay. Pardon me? Yeah. You know this stuff? Nine times x is 9x times x is 9x squared times x, 9x cubed, or 9x to the 3. I could have. Instead of this 3, I could have done it with that 9, but I would still get 9 on top because I would have to uncross that and have a 3 here. 3 times 3 is 9.
I quit. That's irrelevant.
All over 2.
Irrelevant. I'm wrong. No. My dog jumped out of my window at the my house.
Now, there's another way to do these. Instead of separating all of these into their prime factorizations, you could look at number 7. Remember, this is m to the first, right?
oh,
Okay, so when I go to cancel this, first of all, there's no numbers that I can cancel, right? There's no factors in the bottom that are factors in the top or vice versa. But I do have 1 m down here and I have 3 m's up there, right? I could cancel that out. I could cancel one of the m's out. What am I left with? Okay. So I get 7 times m squared is 7m squared. This is 1. 10 times 1 is 10 times 4 is 40. I forgot to multiply the 7 times the 9. That is 63, right? That's correct, young man. Let's find some more squared terms. Are you good? Flip it over.
my head is actually starting to hurt.
I'm trying to find one with different variables. No, they're pretty much all the same. Yeah, let's try 16. That's a good one.
Good one, though.
Okay, let's.
You combine like this.
Well, you're multiplying. You could make it 4b squared. Yeah, you could. Again, you could multiply across. Because it's multiplication. You could, change order in these. Okay. No, but then you would have to reduce this.
You could take that and it
B,
beats
2 over
squared.
15, and this is b to the first, so you're going to take out 1b. You're going to have how many b's left over? You could do it that way. Yep. Because in Algebra 2, you have to know how to do this, or you won't make it through the
I don't
course.
have to
Okay.
Okay?
Wait.
You have to have Algebra 2 to graduate.
Okay,
Nobody is going to get a diploma unless they get through
literally-
Algebra 2. Huh? You cannot take Algebra 2 before Algebra 1. They won't do it. Yeah, it's a junior class. They just won't do it. If they did, they're not going to give you credit for it. It's not going to show up
I'm
in your
pretty
transcript.
sure.
It's a prerequisite.
Or did I do algebra 1 part 2?
You probably did Algebra 1 Part 2. Yeah, you can get away in this course doing it this way, but
What? So much easier.
let's do 17. There are no factors, no numbers we can cancel out, but we can cancel out 1n and the n cubed. So there's 1 factor n, and I get n squared. 7 times n squared is 7n squared. Because you're going to get into more complicated expressions. You're not going to just have 5a or 10. You're going to have, for example, you'll have x squared plus 3x minus 19 times, x squared plus 4x plus 2, and all over, you're going to have to cancel out quantities. Then you're going to have to factor those and then cancel out. Otherwise, you're going to have to multiply those out and simplify it, which is near impossible for an algebra 2 student. Yes, sir. Oh, no, I did it again, didn't I? Yeah, 63n squared.
I will look for if I come up like that.
It's in algebra 2.
So I will do that in classrooms. It looks like tape.
Okay.
Oh,
Satisfying.
All right, so you can finish the rest of the packet. Oh, Justin, you're here. You're here.